Okay, Assalamualaikum, good morning. I bid to all of you, the supervisor, industrial supervisors, my lecturers, and my fellow friends. So for today, I would like to present my final year project, which is stock prediction using Tensorflow. So this project is supervised by Associate Dr. Azmi and Dr. Chu Yong Chu from RHB. So without further delay, I will start my presentation. So the context of my today presentation, I would like to discuss seven points, which is the introduction, objective, literature review, methodology, result, and conclusion. Okay, so for the introduction, stock prediction is an act of predicting the future stock price and stock movement in both and exchange. So the prediction can be made by various methods, including deep learning. Okay. And then deep learning is a part of machine learning where each algorithm, artificial neural network, is inspired by how the brain functions and the structure. Tensorflow is an open source library for high performance numeric AI computation, which mainly used for its deep learning model. And then the stock prediction has been essential for financial traders to make their decision of buying or selling their stock. A delay in decision making could be disadvantage for those traders. Okay, so for the problem statement, the past technique, which is the support vector machine linear regression, give a low hit accuracy and root mean square error result, and the traders have limited tool to use for stock prediction. So the objective of my project is to develop and optimize the deep learning model for the prediction, and to develop a web application which can fetch reliable data, run the deep learning model, and visualize the prediction. Okay, so for my literature review, I will touch about Tensorflow, the deep learning approach, machine learning approach, and mathematical approach. Okay, so for the literature review of Tensorflow again, Tensorflow is an open source library for data flow programming across a range of tasks. It is a symbolic math library and is also used for machine learning applications such as neural network. In stock forecasting, Tensorflow serves as one of the components providing library of the deep learning. Okay, deep learning approach. So the method based on learning data representation. So each level learns to transform its input data into a slightly more abstract and composite representation. So the deep in the deep learning refers to the number of layers through which the data is transformed. Okay, the first picture is the multi-layer precipitated, one of the model in the deep learning, and the second one is the long short-term memory cell. So it's reside on a recurrent neural network inside their layer. And then this is a machine learning approach. So the machine learning is a scientific study of algorithm and statistical model that computer system use to progressively improve their performance on a specific task. So one of the model is the support vector machine. It's a supervised machine learning and method that can be used for classification and regression. So support vector regression is a form of support vector machine used for regression analysis. Okay, for statistical approach, in statistical modeling, regression analysis is a set of statistical process for estimating the relationship among variables. It includes many techniques for modeling and analyzing several variables when the focus is on the relationship between a dependent variable and one or more independent variable or predictor. Okay, this is the linear regression. This picture shows a linear regression model. So from the past research, I have taken around 6 past research that with their model that use a stock prediction. They make a stock prediction using something like a statistical approach, machine learning approach, and deep learning approach. So for the first research conducted by Zi Yao Kan, they use the time series statistic, machine learning, and deep learning approach, where the model is ARIMA, linear regression, support vector machine, and multi-layer perception. denouncing autoencoder support vector machine. So what they find is that support vector machine with a denouncing autoencoder give better precision in prediction. So the data set that they use is S&P 500, Dow 300 and Nasdaq. And then a study conducted by Baksar Hasyah. So he used a decision sum, linear regression, support vector machine and support vector machine with boosting, and he found out that SVM with boosting machine learning give a statistically result. So the data set that they use is Google and Yahoo. Okay, moving on is research conducted by Fisher. What they use is long short-term memory, logistic regression, random forest, and deep neural network. So what they found that long short-term memory perform better in extracting data and prediction. The data set that they use is S&P 500. And then a study conducted on the deep learning comparison framework. So it's conducted by Weibo. The model that they use is long short-term, wavelet long short-term, wavelet stacked autoencoder long short-term, and recurrent neural network. And they find out that wavelet stacked autoencoder long short-term perform better in prediction the stock index. And then a study conducted by Sima Xiaoming Manamin. So they compare long short-term and ARIMA, and they found out that long short-term perform better with a fewer root mean square error. The data set that they use is M255, ISIC, HIS, GSPC and DJI, and the second one is conducted by J. Hyuk-Hyun. So again, they use the same model, long short-term and ARIMA, but he found out that ARIMA performs slightly better with a fewer root mean square error. The dataset that he used is Australian beer, American beer, and N1881. So the methodology that I use to develop my solution is agile methodology, which it starts from planning, requirement and analysis, and then going to design phase, build phase, testing phase, evaluation, and is iterate depending on the situation. Okay, the system design, the architecture of my solution is that I upload my solution into a server where the server has been Dockerized to separate between the front end part and the back end part, where the front end part I use React and the back end part I use Flask to hold the model. And then the server will scrape the data from Yahoo Finance to get the data set. Okay, the use cases is the user can get a stock API and can predict the stock API, which the prediction part used to get stock API. Okay, the sequence diagram is here, but I think showing in the user interface is much better. Okay, the result and the comparison, this is the graph that I have faced yesterday. So we can see that linear regression expected that the graph should be decline, but then the graph is suddenly move up. This is for the support vector machine. Okay, this is for the long short-term memory, where the graph seems that is become static here without any reducing and any inclining. And then this is for autoencoded long short-term memory, where the graph shows that it should be spiking, but it's decline and spike here. Okay, so this is the the result of API response, which is actually it's come from here. Here, the user interface is the first home page that you saw when you guys use my application. You have to input the symbol of the stock price, which example for the Facebook is FB symbol. So when you enter FB symbol, if you want to get the API result, so you will get something like this JSON file. And then if you use for prediction, you will get something like this graph. Okay, the conclusion of my final year project, due to unpredictable the stock market is, the prediction graph can't show a good prediction, but the best prediction is still shown by long short term. And then both React and Tensorflow require more memory and processing power, thus high performance machine needed to be used with the machine. And the end product, which the graph presented, is easy to be understood by all people. So I would like to thank Dr. Azmi, Associate Professor Dr. Azmi, Dr. Chu, and Dr. Novia for guiding me through the project. Okay, thank you. Sorry, I
said both React and Tensorflow require more memory and computing powers, right? That's why I'm understanding the React is on the client side, Tensorflow is on the server side. Okay. So I don't think this statement is very well suitable for the high performance. Alright. Because I don't think React uses a lot of machine powers to processing.
I mean that the React use more memory and processing power is that it's served by Node.js.
Based on my experience, not sure. Okay. So Tensorflow is correct, but this is
the React one. Okay. So I will fix it later. Okay, maybe for the first one, actually I have to mention that this is the today's data. So this is the data that I grabbed yesterday. So it's a Facebook data. So there have been a lot of things happen in USA with the trade war and stuff. So the market become very unpredictable and stuff. Okay, another question.
Thank you, Amir. So if we take a look back at our history for FYP here in our department specifically, we have not had many takers on prediction topic of interest, but Amir took up the challenge and we want to thank him for his effort. So I would like to